I don't have that, no. But this is my email. You can reach me in this place. If you want a copy of the presentation, obviously, I have a pen drive here. Okay. This is bad news. I really think that this is a very interesting talk, or can be a very interesting talk. But I understand that okay, let's start. It's okay. The initial goal of this presentation was to learn how to make tests. This morning we have the real introduction about what is openQA and the history of openQA by the real developer of openQA. And this workshop is to try to teach how to make tests and try to explain the difference between the version that Bernhard is explained and the current version, because I am part of a small team in SUSE, that is the openSUSE team. But if you are in the side of the community, we are the SUSE team. And during the last release of the 12.3, we find that we find two things: that we really need to invest more effort in the QA, because the usual user of openSUSE expect this quality, and we think this release was the first one with the secure boot thing. So we discovered sadly that to make tests, we need to make tests in a virtual machine, we need to spend a lot of time manually configuring different things. And we try to really put openQA at the final end of the release process. For every milestone or important milestone, for every beta release candidate, we, as a team, run all the tests again and try to figure out if UF is working or not working properly. We try in real machines. We can't only trust in the virtual environment. But always there is a combination of variables of configuration that breaks something. Okay, we try openQA, and for our purpose in this release process, we find that we can change something in openQA to make it more easy. One of the things that we changed was in the talk, Bernhard talked about the MD5 way to check to assert if an image is present. Also, you make a question about how to be sure that the synchronization process of sending keys and expecting that this case processed correctly before you check the result. This kind of thing for us was very important, was very critical, because it was very easy to put openQA in something that we call monkey mode. Start sending events of keys, and it's in another path of the test, and it's sending, and we don't detect very early that the test actually was failing. So we rewrite certain parts of openQA. Essentially, the critical path, the critical thing that we want to make sure that we are testing properly is only the installation process. We believe that if at least we really deeply test the installation process and we are sure that everything was fine from previous release, from scratch, using LVM, using encrypted file system, we have network, we have zipper working, and everything that is related with the installation process is working. If some application is wrong, we can submit a fix for that. Hi, welcome. No. We can submit a fix for that, and we have time to fix the distribution after the release. Essentially, if you assist to the Bernhard presentation, you can see that with openQA we provide the test that usually is a Perl code, a very small Perl code. We usually provide the estimate that we want to test, and we have different parts. We have different components, and one of them will create itself the virtual hard disk, a set of environment variables that are used to explain to the test what are we expecting to test, and the engine will configure everything and start running the different tests. The new architecture of openQA is a bit different to the old one. For example, in this version 2 rewrite, we include the concept of a worker. It's an agent that we can use. We can use an RPC protocol to communicate with it, but it's an agent that creates all the calls to run the core thing of the test, that is the OS auto-inst module. We have some change in the user interface. We have some change in the core of the test, mainly related with the way that we analyze the image, and we have some change in the way that we communicate with the virtual machine. For example, we need to be very sure that the communication for the virtual machine is robust. If you are sending information to the virtual machine and you are not very sure that the key is actually executing and this kind of thing, we can lose events. Yeah, I think so, yes. So we change completely the way that the OS auto-inst is communicating with the QEMU. We have now two different ways of communicating, both provided by QEMU. One is a telnet communication, it's the human interface expected for QEMU, and another one is a JSON protocol that is very useful to dig into the QEMU internals and send advanced kind of commands. This is a workshop, and initial goal was how to make test. I propose in this workshop to install openQA and try to play with it. It's very, if everything can make some exercise in the workshop and check the results. If you want to install, it's very easy. We have created during the past projects, the past iteration of the project, we create proper package for to simplify the deployment of the application. The dependencies are very small, but all are in the Perl project of openQA. Only one dependency is QEMU, and this OBMF is a package related with secure boot. One of the things is that now we can properly test with Piano Core, this a BIOS replacement. We can test secure boot in different configurations with US with secure enabled, disable, with the key that Microsoft provides, the key that SUSE provides, whatever kind of test. Also, we have different mediums. One, the user can copy a medium in a DVD, copy a medium in a USB, and the same image comes from one medium to another. But the boot is a bit different in some cases. We work to make sure that when we are in the USB boot, we are using this openQA or QEMU to test a CD-ROM bootloader. So there was a big work in in test different kind of hardware configurations. If you install the basic packet, this is an additional step that we need to do is install the details. During the test, we are expecting the test time cancel, maybe send some case error and wait until some completion is speed. Usually, the basic language of communication is an image. An area, a set of areas is an image. We call to this image, we call it needle. This needle are stored in a different repository, and there is a small script that download current needles in the download the current needles and deploy in the proper way or in the expected way inside the server. And yes. One of the dependencies is Apache. Apache is the responsible to start the communication with the user interface. It's the one that renders the HTML and with CGE communicate with the component that read the current status of openQA and show some results. If you work with the previous architecture of openQA, you will have an interface that is web-page and has a database against. But to be honest, we find that it's very difficult to start a new test from scratch. So for example, today I want to test an application, maybe Okular, I want to test Okular. Maybe I want to test OpenOffice, LibreOffice, something that is related not with the installation process, something that is before the installation process. We found that it's very hard to use this kind of tools, this user interface, the web user interface, to interact really with the test process. We are expecting something more, because we are creating a test, something more contained, something that we have more control on. So we need maybe an editor, and we are writing some tests and some Perl code, and we need to run very quickly this Perl code to check if I am making a mistake in the test, because in some way I am making a program. I need some agile form to go and come back from the test.
Like a record button.
Exactly. We need the fast run button to run this module and to check that. For that, we create a small Python script that help us in this process. If you want this approach, there is a different dependency that you need to resolve, but this is only optional. The usual process, the usual workflow of testing is the first thing that we need after the installation process is to register an ISO image. What is registering an ISO image? In the usual workflow of testing, we have a new ISO image that usually contains bugs. At least we need to test that it's okay. And there are different kind of tests that we can launch. So there is an application in the system that create the different test sets according to the ISO image that we are registering. We have ISO for DVD medium, 2 live USB, one for genome, one for KDE. We have a rescue image. We have the net install, and obviously the tests are different. It's impossible to test in the genome live DVD, KDE, for example. So the set of tests are obviously dependent of the ISO that we are testing. So we need a way to discover what ISO do we have and program for this ISO image the different tests that make sense for this medium. Also, we need a way to start the workers. The workers are the agents that will take one description of this test, take this description, and start launching the different tests related with this medium. We will see an example now. Okay, this is a screenshot. If we successfully register a new ISO image, we can go to the URL of our servers. If we are running in our desktop is localhost, we can launch the worker uses systemd, or there is a small command line that can manually launch the worker, and we can see the test running using the user interface or a VNC connector. We have open a VNC that we can use to interact, to change the behavior of the test. I have an exercise here that we can do together, that is register a build ISO. This is milestone 3, I think. Try to run in the system and test only the KDE test. Let's try that. The last time that I tested failed for one very interesting reason. Okay, if everything is okay, we need to register the ISO image. There is a command line that is RPC that sent a small command. In this case is ISO new to one server, in this case localhost, and we have a pointer to a path for the ISO that we want to test. This 20 that we can see here is according to the name of the ISO image. We decide, it's something that we can change, we decide that we are going to run different test sets. It's different configurations of the test that we can see in our new installed virtual openQA. These are the 20 different test sets that he wants to test. For example, one of them is a KDE, other one is a UEFI mode, minimal X, genome, different configurations of RAID, XFCE desktop environment, LXDE, I mean a different set. To make this more agile, if now I launch a worker, the worker will take randomly one of these tests and start executing the different test units inside this test set. We want more control. We are going to cancel all the jobs, all the test sets, and stay only with the KD one. This is only that you can do that only in the new release, in the one that is now public available in the openQA web platform is something that is not yet. Now it's time to launch a worker. We have systemd to do that, but we are going to use a manual approach here. We are going to launch the worker script and launch only one instance of a worker. If everything is okay, this worker we see yeah, everything is okay. It's a job, and the first thing that try to do is configure this virtual hard disk, in this case a QCO2 image, launch a KVM, and start executing the test. We are seeing garbage here. This is some debug information. This is very interesting because we are seeing the communication between the OS auto-ins and the virtual machine. This blue text is the event sent from the OS auto-ins to the virtual machine and the response that we have. And we can see, and this is something that we see in the Berhan talk. Where is KVM? It's running now in this laptop. You can run KVM without seeing the graphical view. In this case, it's configured to don't show me please the graphical view. But we can see what is happening in two different ways. The first one is using the web interface. This is what is happening in the test. At the left side, we can see what kind of test is executing, but we can use the VNC viewer that, let me check where is the port. Localhost 91. This is something that you can configure to put in a different way. And we can see again where is the test running. You have the same view. You can change from VNC to the web interface, but you can see the same result. Obviously, the methodology is different. One is based in screenshots, and another one is the VNC protocol. This is now our system is running the virtual machine, and if we wait enough, we will see that it's failing. Something will become red, and we need to figure out why it's red. The usual thing is there is a problem in factory. We are testing all with factory. We are not testing final release, so it's normal to find problems, and that means that openQA made his work. But there are another kind of problems, are the needles. The needle, the thing that you use to make the assert, is not matching with the actual thing that we see. And this is because maybe they are changing the artwork, they are changing free type, they are changing the fonts, icons, and everything. If there is a real important change, we will see that the needle is failing, and our work is create a new needle using the web interface to fix the problem. Yeah. So if the failed test is again, we have two options, maybe three. A real bug, so it's okay. A bug in the needle, or a bug in the test itself. I talked, the test is running. If everything is okay, it will fail. I will see that it's failing. But I want to explain something about what is really a needle. This is something new. It's not in the openQA thing, in the openQA deployment that is in the user in the openQA.opensuse.org. A needle is a PNG image with a JSON metadata. It's a JSON. It's a JSON document that is describing certain area of interest inside this image. You can have different areas, 2, 3 areas, and with different types. We have actually 3 types of area. A match is something that is, we are expecting that openQA find this area in some place, maybe not in the actual place, but in some place in the new screenshot. We have an exclude. An exclude is used to try to make a blind point in OpenCV, that is the library that we are using to image processing. A blind point to maybe remove the certain things, certain areas that are changing very frequently, for example, a timeline or the cursor or something that usually change. And we have an OCR area. If we have a point that is an OCR, we will use a tesseract to try to convert this area in something that we can parse, maybe using grep or whatever. So let's see how is the test running. maybe, oh, it's still running. Again, if everything is okay, we will see a fail in the second stage of installation. We have this is something that was all. We have a live log. Below the screenshot, we see the status of what is happening, the events that is sending openQA, OS atoms to openQA, and if we are waiting some screenshot, we see a wait thing. This, for example, we see a node change and a number. This is that means that the test is making a wait, is waiting for something to happen. And with the percentage of overlap between the current shot and the thing that we are testing to, the needle that we are using to make the test. Let's wait a moment, because this is not a very powerful laptop. One of the things that I was discussing with Adrian is that we can run all these tests without the user interface. So we can reuse certain components. Maybe we can integrate this, the second part with Jenkins or whatever tool that can be used to guarantee or to make a continuing integration process in our release process of the distribution. We have finished the installation process. If everything is okay, the system will restart. One thing that we will find very useful below after the installation process is that we have like 3 different areas in the right side, the test module. One is a set of tests related with the installation process, a set of tests that we are testing console applications, and a final test where we are testing graphical applications. One thing very important is that fail one test, one single test during the installation process is obviously much more important for us than to fail one single test in the console or in the graphical application point, one test of the graphical or console test. Because if you can guarantee that the full installation process is green, maybe we have something that the user can't use to fix or to update the distribution. We can send maybe a fix for that. So a fail in this stage means that we are going to stop the rest of the test, because we need to fix before making proper test to fix the installation process. And this is the point where this build must fail. We can see that it's waiting for something. Nothing is happening in the user interface. There is no bar moving. There is no action sent. It's waiting. And we will see that the reason of the fail is because the artwork and the position of the relative position of the different components of the view change quite heavily. But it's something very difficult to see because if you see this screenshot, looks like that everything is okay. We will see in a moment how to discover that and how to fix that. It's a matter of a minute.
What test was supposed to do this test?
We are testing KDE. So we have a set of tests only to test, in this case, KDE. Yes. To test KDE, we need to split all the tests in different and smaller steps. So in the right side, we see the test units. For example, the first test, the name is ISO size. So we are testing that the size ISO, the size of the file, is in certain range. If it's wrong, the color of this test will be green, will be red, and we are going to stop the test. The second thing that, sorry.
In general, it's already very successful that it starts. I mean, this is something that can easily get the developers update some package, it breaks so much that it even does not start. And with openQA, you get automatic notifications that you broke it in general. So even just does it start at all is already very important.
Yeah. You can see that the next one is the bootloader, welcome, installation mode, install time zone. So we are testing small steps and we are pushing the installation process in every test. If everything is okay, in this case we see something red, but if everything is okay, when the finish, that this is the last test of drop name is green, in this point of the test, we are pretty sure that the KDE installation method is installed. Maybe at the sense that the thing that we are testing with the test, with the coverage is not full. The resume, a video to the process, but need to check for the requests. And the one that is second image that's there, I will see what make real in case red. That is happen. This is something this is present in the current QA deployment. We are taking as a benefit that is making constantly assets. The asset is the thing that we have in the screen. Every asset is using a needle. In this case, for this test, we have like 5 different needles related. A fail here means that no one of those needles is a perfect match, is a match with a certain grade of fuzziness for this test. We have a scroll bar here, how is it mapped different areas of interest. Let's see that because milestone 2 is, we can see if we came from this KDE to milestone 2, we can see that obviously the needle is different. There is a different position in the Firefox icon. But again, it's different. And again, with the milestone 1, the milestone 1 was very, yes, the artwork is different. And with this one. Okay, this is very similar, but okay, we see that. Did you see below? Yeah. This needle is very interesting, but it's only trying to, it's an example of a different kind of needle. With the needle, the thing we have. The option is create a needle. And we need to make it very fast because most of the time, in this case, every contributor can do that. It's something that you don't need to permission to do that. Match. Let's forget now about match. It's a bit advanced. Areas. With areas, we are selecting the areas previously. This is not we use a different set of fields from, and this is the case. Because this area is full. is full screen. But we can change and select different areas. We can create different areas. And that I am changing the area, the JSON document, this metadata obviously is updated here in my left side. You can see, okay, I create a new area. For this case, the correct response, the correct thing is we want to create a full, one single area that is the complete screenshot. Obviously, this is not the more robust approach. The more robust approach is to try to select the areas that are important to the meaning of the thing that we are making the asset. But we are very lazy today, and we want the full screenshot. And the tags are used to find the proper needles inside the test. So the test in some moment need to say, okay, try to make a match from the current screenshot to this small set of needles. But how to reference these small sets? Using a tag, using a label. So we are going to reuse the same labels from these needles that we are using. We can change here in the tags column, we can create new labels, new tags, select specific ones or remove some ones. But in this case, I think that it's related with the KDE desktop environment, it's related with KDE, desktop as first board, desktop after installation makes sense for, if we are making a mistake, we can edit this thing. And now we can create a needle. Yep, looks like that the needle is created. The name is a bit strange, desktop at field boost, KDE, and a timestamp. That means that this is a good point as a tester to check if everything is okay. We can relaunch, we can restart the test, and maybe we will have a green, full green in the installation process.
So how is the needle being put into the testing? How is being put in the order to be tested?
The order. Okay, this is let's see that. Yes, but one step in a moment. There is a moment when we will see that. But yes, obviously this is important. Let the worker continue the job. Okay. This was the first exercise. Okay. Now we need to dig a bit more. We need to see how is the test side. We learn how to think about testing in openQA. This is another exercise. With this exercise, the thing that we were expecting was to respond your question. How is the difference stored? How is the order laid? We have C groups. How is grouped? How if I want to create one new test for installation process, where I need to put this test that I don't know how it is. We are programmers, so we can try to dig into this to figure out how is this thing. The approach that I was suggesting here is to dig to watch the content of the package, because usually this is where more information we can have. Okay, let's see. This is the content of the OS AutoInst package. This is the core thing of the installation process of the openQA. And we very soon see something that is very similar to one of the labels. We see inst x11 test, but in this case we are seeing SLE. If we wait something. Okay, this is openSUSE. So there is in in this case USR lib OS autoinst. We can find the different tests. Let's visit this directory. Okay, we see the inst directory, console test directory, and x11 directory. Obviously, the real tests are here. And we see the order is related with some number, very similar to system file order in the script. We can see that is a similar approach. Also, we see clearly that this PM extensions relate with, they are per module. Let's take one easy test and try to figure out what it contains. For example, LibreOffice. Yep, LibreOffice. This is one single test. We see that it's using some base class, that is base test. We see is applicable function here, and obviously it's related with something that is a variable environment, that is desktop. We can see very easy that the core of the test is in the run function, and we see wait for the screen, send autotype and text, send K with a description, a textual description of a test, wait for middle with in this case a very long string, Office Safe Pro, and X11 start program or writer. Obviously, we don't know how, maybe we don't know how it's working, but obviously it's launching, with the script it's launching with this macro is launching the writer OpenOffice, is waiting for something, is checking something, is sending a text. I know that I think that the one who writes this script is working in the LibreOffice, in the writer. We are sleeping, we are checking something, sending Alt F4, Alt F close the close command. We are waiting for something. In this case, the task, the last variable is waiting for the safe prompt, and we are sending Alt W and sleeping again. And obviously, it's saving without exiting, without saving. This wait for middle?
Yes, it's number 8.
Okay, yeah. What is the number? Yeah. Let's wait. But yes, it's very important. Also, it's very important. Is sleep. It looks like very stupid to sleep in a interactive mode. We are in interactive mode. Why we need to sleep? Yeah. This is.
Sleep 2 seconds there.
We are sleeping. This sleep thing is from Perl. It's a thing new. If you Perl, you can see that everything is Perl except this script, the check screen, send autotype. This is some functions related with the class that we are, and this is not Perl. This sleep. Yes, it's Perl. Okay, let's see how it's run. Okay, it's still running, but we are not in the stage. And we have now a more clear picture about where are the tests stored. Something is in a directory that is related to the testing, in this case openSUSE. We see 3 different directories that are grouping the different tests and a number as a press of the to order, to have a order between the tests. But where are the needles? A few moments ago, I created a needle. Where is this image and the JSON thing? It's in the same directory. It's in the same directory. It's needles, but it's a soft link. It's a soft link. This is important. And see, I want to see what is in Needle. Needle is a directory with a bunch of JSON and PNG documents. Obviously, it's in pairs, and it's a directory. During the deployment of the applications, one of the things that we did is execute a script that cloned the repository to our site. And we have just created a new needle. And a new needle that, if everything is okay, will put in green a test that was perfect, but only the needle was not perfect. We have very easy now to add the needle and create a small contributions. Oh, this, you need to make this as a root, because the owner of this thing is a root, because it's a soft link. We can move this directory in another place and put the proper owner. But I mean, this is very easy now to contribute. We can add the needle and push to the repository, and we are contributing in a very interesting way to the project. Okay. I want to spend only a moment in this part of the script. We are trying to see if some environment variable, in this case desktop, is a KD or genome, have a KD or genome value, and it's inside the is applicable function. It's very easy to understand that. It's very easy to see that there is a call in the OS@OINS is calling before to run this test, is calling is applicable, and we have a true value. We will put this test in the queue of valid test. So we are using this test, we are using a channel of communication between openQA and the test, that is the set of different variables that he's setting for us. In this case, we are using one variable to check if the test is okay or not okay for this test suite. But we can use, during the run of the test, different set of variables to change the decision that we make when we send an end to our example. We are testing maybe the logic of communicating is so complex and so different between every kind of write test. We only need to check if we are testing one kind of write and adapt the second. We are making a condition inside the run test for this case. And we have a set, a very big list of variables that we are using to communicate with OS@OINS with the desktop is one that we see. We have KD, genome, LXDE, minimal X. We have more. Server, only text, to execute in only text mode. We have more. Also, maybe we want to test something very specific related with the way that we are booting. Maybe USB boot, maybe it's important to make a proper call. Live test, netboot, the file system we want to install, but system, encrypt LVM or not encrypt, the level of the write. Maybe we want UEFI with secure boot, UEFI without secure boot. All these things need to be copied to the test, and we are using the environment variables to these communications. UEFI, you know that there is BIOS is a bit deprecated now, and the new machines are selling with UEFI BIOS. It's a new kind of firmware, and this for us is very important because because Windows 8 and Secure Boot change the boot process. And openSUSE has signed the bootloader, and this is something new that we need to test. So we see send only one single keystroke, one single event to the virtual machine, and send a type that we use to send a set of keys, a text. Also, we see a number after the send auto type. In this case, in the previous example, we don't see a number in send auto type. We see a number in another function. In this case, means a delay. We want to send the key, but not very fast, because maybe we are in a graphical environment and we can be really fast writing, because maybe the operative system or the virtual machines can confuse a bit. So please be slow, don't write very fast. We have a dictionary, a map. This is the CMD, the command that we can use to map certain normal actions to a specific key. For example, in just, usually the next button is associated with Alt-N, at least in an English local. So we can have set a convenient map for this kind of thing. But the real important API that we have in the test is wait for it, and have two parameters. First one is the tag. This is small information that we put in the JSON document that we use to find the correct needles that we need to make an asset for the current screenshot. And the second parameter, that is what Adrian asked a moment ago, is the timeout. We are waiting for this set of needle, only one match is okay for us, during this number of seconds. For example, if we are in the process of the installation, maybe the installation process is half a minute, but maybe it's 2 minutes, or maybe, I don't know. So we need to that. And after that time, if after that time we don't find any needle in the current screenshot, any needle that matches with this tag, we have an asset, a failed asset for this test, and we stop testing, at least for this test. This is a hard asset, but from time to time we don't want a hard asset. We only want to check certain state, and check for needle is for that. Check for needle is the same that wait for needle, but instead of stop the process, instead of stop the return true or false if there is a positive or negative match. A check screen is something that we see in the OpenOffice test. A sometimes convenient way for a call of wait for needle. In wait for needle, we need to write a tag name and a timeout. In check for needle, we have a way to create names for the needles that have some sense. In this case, it's the prefix test, the name of the test, and the order of this check for screen. So the first check screen is number 1, the second check screen is number 2, 3, 4. So we can create, instead of think about different tag names, we can use this convenient function and
if you're using a different resolution, I'm just going to have different images from your
this is for us was previously to this sprint was a very bad problem. Was a very bad problem. Was very disgusting, because if you for some reason change the resolution, all your database of needles is not okay. So we make sure that we configure QEMU and the bootloader to set a specific resolution. We enforce a certain resolution. So there is a test in a very initial step that instructs the kernel to set a proper resolution. And this was a very bad problem. Also, one of the initial approach was resize the screen. So we have the database of the needles in a specific resolution, but we can see this ISO image is running in a different screen resolution. Take this resolution and adapt and resize to the other one, but we found that was not a very robust decision. So we fixed the resolution during the execution of the test. Okay. This is another thing that we learned, the directory layout. Okay, and now we know that we have the isable and boom functions inside the test, but there is a third function inside the test, that is test flag. So we have isApplicable that is called before the test, run during the test, and test flags after the execution of the test. We use test flags to have the chance of mark certain test as a very important. So if we think that this test can fail, because if fail, it's better to stop testing anything else, this is the place where we can describe what to do after the installation, after the asset or the final result of the test. We need to return a dictionary, a map, and we have 4 options. If fatal is true, we stop testing everything. If it's important, we continue testing, but we mark this ISO as a broken one. This test is important, but we know that we can make further tests to discover new bugs in the ISO image, but we can consider this ISO as a valid one. Milestone is something that we can do with QEMU, that is snapshots. With QEMU we can say, okay, make a snapshot, and the memory, the CPU status, and the hard disk are all frozen with a single label that we can reference and relaunch QEMU wherever we want since this point. And we are using one general label, one general tag that is last good to store the point where the last test was okay. And if we don't return anything, we are saying to openQA that if this test fails, mark the test as a fail and do a rollback to the last good snapshot. So that means that the next test will be as a big moment. Okay, let's see how is. Oh, fails again. $95. Where's the difference? Why is it? Okay, I don't see the difference. Maybe it's the mouse cursor?
Mouse to the left.
Sometimes it's the timer, but the timer is the same. The desktop. Oh, really cool. I don't see where is the difference. What? Yeah, but maybe it's very spread. But yet, before we have this solution, we did exactly that. We mark we mark the screenshot exactly as an OpenCV see the screen. So, but from time to time we have a very random noise because the change was spread over all the image. So you don't see anything, only very small gray areas. Yes. We can change the threshold, yes. And in fact, the solution for this problem, change the threshold. But I think that
Probably
to the left.
Yeah, with the sidebar, the sidebar of the window.
Oh, sorry, the left. I wasn't in my right. Let's check that. Okay. I don't know really.
What is that, 95% mean?
Means this are 95 in both the needles and between the screenshot. So they are very similar, but not enough for a perfect match. We have three different solutions here. It's time checking the difference because we didn't in KD or in some place. Maybe there is a hint somewhere. We have the change. In fact, I don't see the difference. If I don't see the difference, usually it's because it's spread forever for the full image. We can change the needle. It's another option. Is go to the needle and change the needle and make a proper one. Select all the areas that are important. Oh, I think that I know why. Yeah. In the original needle, this area was excluded. Was not in the. But in my needle, yeah, this is the difference. Sorry, I make a mistake creating the needle. The difference is in this corner. The time. This area was excluded. Okay, this is very easy to fix. I make a mistake creating the needle, a proper mistake. It is exactly the same, but the metadata is different. So I need to change and exclude the time here. It's very easy to do. Another solution that I hope is the one that we will enforce is create needles where only the important areas are matched. Don't be so lazy to create needles that represent the full approach. Now, if everything is okay, this needle is a better quality one, have a better quality one, I need to work.
So now that has created another needle.
Yes, I created another needle. I can remove the previous one as a file, so I can do that, or I can whatever I want. Another option is to the JSON document is something that we can edit very easily and fix the text very. This is something that actually we do very fast. The tags, we usually make mistakes in the tags. So, for example, we know that the text is correct, but the needle is not present. Why the needle is not present? And I remember generating a needle for that. It's because I make a mistake in the tag. So, for needle is not found the needle because it's when the label that I am using is not present in this.
Now we've created a needle with 3 separate areas.
Yes.
How would you create a needle excluding areas?
Area, for example, something like that. Let me put this example. for some reason I want to match this, but not this second openSUSE. So I create a exclude area, doubly clicking in the area, yes, and putting as an overlay in front of the same region of that. So the matching is with the icons and this small test. You can see the description here that we have a very big match area and a smaller one with type exclude. So you have this editor for that, or you can and this is okay. I have a fourth exercise that is for something. For example, we are in KDE, maybe we can test ocular. If we are in genome, we can test Evans, something that we can do. How is the shape of this test? This is a very easy and very similar to the one that we see with OpenOffice. Usual approach is always copy the test and change whatever you need to change to have a new test. And this was my proposal. I tried to use only the API that we see before. We are using the base test object. We are this test only will run in a KDE test. If we are testing genome, we don't want to run this test. And we are sending a set of very known keystroke. Alt F2 to run the, if I am not mistaken, to run the to run the command line in the top, at the top. After that, I want to write ocular, press return, wait for a needle that show ocular in the screen, maybe put a needle, a specific needle that consists only in the title of the application, maybe a needle that represents the full ocular application. Wait 5 seconds before make a fail assert. After that, send Alt F4 to ocular and return. The sad thing is that the logic of the test is very clear here, but there is a good chance of a failing test. And the reason are the sleeps. We need to put from time to time certain points in the event to wait more time than we expected. For example, the Alt F2 have a delay. It's not, if I press Alt F2, there is a smooth screen that if I start writing very fast, this next command will be lost. Maybe this delay in ocular and the return key. Maybe this sleep is a bit excessive and is not need to use it.
So the wait for needle has embedded sleep to in it, or do we need to put it in that 5? So that 5 seconds is an embedded sleep to in it. The thing about it that
is a bit different. The sleep is to give time to the test, and to the operative system to run the event that we send, yes. And the wait for needle is the Windows 10, the time window, sorry, that we need to wait until we make a fail assertion. That means that if this value is very small, we will fail very soon. And maybe if we wait 2 seconds more, it's okay to have a positive test. So we solve this issue in 2 different ways. Maybe we can put an sleep before these 2 in the timeout. I would prefer to add the 2 in the timeout. Wait 2 seconds more.
How do you decide what sort of number you put there?
How try and error.
Why is it a 5 and not a 7?
Yes.
Or a 6?
For example, if you have a slow server and you are running only one instance of openQA, maybe 5 is normal. You can expect for a normal application wait more than 5 seconds until the application is shown. If the server is running 4 instance of openQA, 5 is a bit small. So it's, yes, something is a bit nice.
So the tests that you are running are based on the CPU speed and memory and so forth. So these values are dependent on the actual hardware infrastructure and how many virtual CPUs you've given to the virtual machine that you're running.
Yes, but we found that this has a secure area. If you don't overload your server, the normal value that you put here is the thing that you expect in a real machine. For example, wait 10 seconds for launch Ocular is wrong. Because if Ocular appears after 20 seconds, but after 20 seconds, maybe there is an error in IDE or in Ocular or in the file system, or I don't know, but there is an error. So the time that you can expect from a real machine.
But it wouldn't be, is there some sort of guideline that you give what sort of numbers, depending on the hardware, that we're going to do the tests?
Yes, there is a dependency.
Set of guidelines on that?
Yes, the first guideline is a bit more that the thing that you need, the from a machine. I mean, it's if I run Ocular, I think that I only have to wait like 2 seconds. Less than 2 seconds. So 5 is a symbol because again, if Ocular spend, if you need to wait 20 seconds to Ocular, I ensure that there is no problem with KVM. There is no problem with your server. There is no problem with your setup. It's a problem with the thing that you are testing. But maybe 5 seconds more, for example, to install it. Maybe you need to wait 10 minutes. Again, after 10 minutes, the installation is not done. And it's done in minutes, but it's done. I'm certainly sure that it's a problem in the ISO. So the rule is try to put a bit more perspective from the machine.
What I'm trying to figure out is whether it's empirical.
It's empirical from the actual. Yes.
You run a test to get things.
Yes, but
and then tune this thing rather than. I would think that putting variables there and setting it as environment variables at the start would take a lot of that wizardry out of those tests.
Yeah.
Say I've got fast box, put in fast, and then these tests in the environment can be set differently rather than going to every single test.
This is true. In fact, this is so true that this sleep 2 is more evident for me. I don't understand in this example. This is fixed, but I don't understand what we need to do after every 1 to sleep seconds. This is wrong.
It's a Perl quirk.
Yes, but we have an abstraction layer. It's the thing that we need. I think that the logic is here, but it's a bit hidden because we have sleeps and magic numbers and a timeout. This is a bit hidden because of that. And if this is the problem that you spot here, it's true. This is a problem that is wrong because we have another level of abstraction. We have a small function that is script run, sudo, x11 start program that internally are doing exactly same K alt F2 sleeps on time, but you as test writer you don't need to worry about these details. This is the point that I agree with you. This is wrong. The sleep thing is wrong. You need a higher level of abstraction. And in fact, we have some helpers, small scripts that help you to abstract the common tasks. For example, running a script in the terminal, running a script program in a desktop environment, and one very interesting, running a script as a root user. I mean, how can I run a program as a root user? If I use sudo, I have the chance that the operating system will have a root password. But maybe the second time that I root as a root, it doesn't ask me for the password, because sudo, there is a window when he allows you to run the program as a root without asking the password. And this is a bit tricky. We need the correct level of abstraction and the basic API to guarantee that we can detect the condition when the system is asking for us for a root password or not. And this is an exercise that for me was very interesting. With this basic API that we have, and we described very early, wait for needle, check screen, and take a screenshot, and send carefully, can't we implement something that change the behavior like sudo, that enter the root password when it's asking for that, and don't enter the root password when there is not? Can we do that? And just try to think about that, and we can do that. And this is the shape. This is the basic shape. This is the pattern. We execute the command, and we don't make a hard assert. We are making a check needle, a subset. So we wait for third time condition, sudo prompt. We have a small needle where we have OR that's asking for the root password, and we wait maybe for 2 seconds because more time is stupid. If we detect this image, we are going to send, in this case, the password and press return. But if we don't see during 2 seconds this prompt, we are done. This pattern is encapsulated in a function that is a script. So we have a convenient, we can combine the basic API and make a complex thing like this script sudo. Over time, we will see more complex situations when we need to check to make decisions more way to abstract. That's again in procedure level. And the most complex case that I can think of are the more cases is that you remember during the installation process where the point of failure of the installation process, we see one needle and in the left corner a small error message. Okay, this is related with that. We have this scenario. We have the ISO image that is nearly perfect. Only from time to time a pop-up appears. Say error is but this is bad. It's an error. We want to function process. we need to make sure that this is an error, but we want to continue the installation process. The problem is that this pop-up maybe doesn't appear, and maybe appears 1 time, 2 times, 3 times. It's random. We don't know when appear, if appears. So we need a way to have a very clear picture of the current status of our test. And with this script, with this small template, we show a way to have this status. So in this case, we are creating 2 different sets of needles, a good set of needles and a bad set of needles. And we reference the good and the bad set of needles only for the tags. And after that, we are going between a needle and what needle do we have? Is in the good set or is in the bad set? If it's in the bad set, we are going to take a screenshot. Why? Because we want to annotate in the execution of the test that something wrong happens and exactly what happened. But we want to continue the test. After we are going to press down. In this case, the dialog box will disappear. We mark this test as an error, but we continue the test until a good test, a good needle appears. If a timeout appears, we are wrong in the bad test, this test is failing. Or if error is present, so if we found only one single bad needle, this test is also wrong. But at least we continue the test process. I think that this pattern is complex enough to see that with a good and basic API, express complex thing and complex condition with a higher level of abstraction. We have a more advanced API. One of the questions during the rehearsal talk was about the mute mouse. We can find, we have the basic API to find the button to move the cursor button and to simulate the click. In our repository, we have a version of QA with this fixed with this package. Also, we have a channel of communication using the serial port and an API related with this serial port, and a very basic API to create and recover a snapshot of the virtual machine. And maybe it's useful to have these abilities inside the test when we are trying and roll back by ourselves the status of the virtual machine. Maybe we can try some experiment, run some action that maybe break completely the environment, and we have the opportunity to make a rollback and come from the beginning of the test. And basically this is the content that we want to show, that we have an API, we have several actions. This is how we do a test. The core of the work is sometimes only creating needles, and to create a basic test is not much complex. That we have, we can reuse the logic of the test using a high-level API to again contain the logic without these ugly details that are the timeouts and these magic numbers that from time to time we need to put. And I don't know, there's questions or comments?
Can you run a scheduler on the tests?
We have an external scheduler.
Like, say I want you to start running at 11 o'clock a cron job.
You can launch a cron job, yes. The current architectural approach that we have is modular. So if you want to run a test in a specific moment, you have two options, basically. You can use the right side of this schema, OS AutoInst at the virtual machine, and program a cron job to do that. Or you can use the full stack and use RPC to say to a specific worker that start working at a certain moment. We have a command line RPC that we can use to communicate with this worker. So the cron job is the cron job is very easy to say stop now and start working. So you can control with the scale with the cron job. You can control which worker is working and when. So it's a matter of rpc.pl, stop, pause, and continue to the worker. It's something that you can do. Only one final note. We are currently using openQA in factory, but only at the end of the process. I mean, when we have a ISO that we can test, that we test that. Obviously, we are more aggressive testing, beta release candidate, obviously, but we are using openQA in factory. But we have plans to use openQA before we have a new version of Perl in the factory. This is something that can break completely factory or a new GFC. So we can use a certain test together with openQA to see if it's a good idea to put and accept this new package into factory. And if the test is not green, we can discard this package, inform to the developer that something is wrong, and have a factory that is still working. So it's and this will help during the integration process of factory and to the current users of, obviously, of factory developers or normal users.
Can you put the presentation here because I can't do this?
That doesn't work?
It's a Windows course.
Okay.
Thank you very much.
I'm sorry that that's where openQA will be important in SUSE. We have two versions of openQA. One is the one that everyone is using, and this version is the one we are using. This version is integrated with the Benham integrate the certain parts of this version in his own branch. That means that in the official page of openQA, there appear the code documentation. For now, we have a repository and a zipper available. Also, the description inside the project, but it's not documented. Yeah. We need to fix this at some point. And if everything is okay, as the new version, we will find the deployment information in the correct place that is his home page.
Does anybody know what I have to do to get this thing to display?
Power on.
It is powered. Yes, the LED is on. Yes, awesome. I like it quickly. Technique to reduce locking potential by executing the code just in case, and if you find out later on that you shouldn't have to revert the effect. For example, on my system it's TSC, means that I have a stable TSC. Yes. And if you dig long enough into this thing, then you will see that the TSC code does not use a spin lock. The same is true for the ACPI code. I have not yet checked the HPAD code, but it should be.
An order is an order. No, I still have time.
Sprech.
There we have it.
Test, Test, Test. Sprechprobe. Der Sinn dieses Testes liegt in seiner schieren Existenz. Der Sinn dieses Testes liegt weiterhin in seiner schieren Existenz. Test, Test, Test.
That was the sense of this test is its mere existence.
Test.
Jo.
Hier, das müsste es sein.
Oh.
Ist das an? Das haben wir nämlich heute Morgen schon verwendet, deshalb. Müsste
Test, Test, Test.
merkwürdig. Heute Morgen hatten wir nämlich...
Mhm.
Test, Test, Test.
Geht das?
Geht das? Na gut. Okay. So, what time is it? I'll give them another 2 minutes, unless anybody objects. Yeah. Was worth waiting, but I'll give people another minute. Okay. So, this is a talk about speculative execution, and I will begin with defining the proof, then the method, and then the implementation, and then talk about the status. So, speculative execution aims to reduce locking. To understand why this would be desirable, I have to show you why locking is bad. Locking causes contention, and contention hurts scalability. To avoid that, locking has to be made as fine-grained as possible. That is, multiple CPUs must not wait on the same lock. To achieve that, we break down our locks to the smallest possible parts, defined by which parts of a data structure must be changed atomically. That has consequences. our data structures grow. Now you may tell me that you have a shitload of RAM. Then I tell you, you may have, but you do not have a shitload of cache, and your working set better fit into that cache, or you have a problem. In addition, usually you just can't take the fine-grained lock, but you need to lock your hash table, find out the element, lock that, release the lock of the hash table, execute your critical section, and so on. And we have 2 locks taken and 2 locks released. Quite a lot of computation. It gets worse. It's not just computation, it means writing. And it means necessarily writing out to main memory, because all CPUs must be able to see your lock being taken. And to add a bit of sadness, that is in principle, without lasting gain, because if you release the lock, as you hopefully plan to do, it's back in the old state. Nothing gained. And, make it even worse, that writing has to be done atomically. On x86 and the 64-bit architecture, you take the lock prefix. That's expensive, about an order of magnitude. And we can make matters even worse. I like this, it's so nice and pessimistic. If you have lock contention, then you are by multiple CPUs in sequence, which means it cannot stay in cache. It will have to migrate from cache to cache as each CPU takes the lock. And that is quite expensive because it requires inter-CPU communication. So, anybody still convinced that locking isn't bad? No. We go to speculative execution. This is the first historical incident of speculative execution I was able to find. It was from the priest of the crusade against the Catholics. It sums up the method. You do something on a mass speculation, and if it turns out that you were wrong, you try to undo the effects. That is the basic principle here. It needs some kind of hardware support, which is being introduced in modern CPUs. The most obvious example is Haswell, upcoming CPU release from Intel, but we know AMD has made public that they will follow up. And the same principle, though in a set, obviously, is supposed to be implemented in Power version 8. In this talk, I will talk about the Intel instruction set, just for the simple reason that that is the only kind we have. Intel itself is implementing 2 versions of speculative execution. The HLE and the really cool one called the RTM. HLE is backwards compatible. It works by one of the prefixes which on x86 translates to NOP. So you can run on older CPUs without change. It's just a bit larger. RTM is not backwards compatible. It has quite some new features and they require use by the programmer. You can tell whether it is supported by the CPU ID instruction as usually. Speculative execution works by telling you that a section of your code is critical, which other CPUs may not enter at the same time, which is the conventional view of this point. Under speculative execution, they may enter and they may do something. And at the end of the critical section, we find out whether this was harmful. In order to do that, you can see all cases in a critical section as atomic. That means they must either all succeed or none of them will succeed. This is done by the CPU not performing write operations. All writes are cached in special buffers and done after the end of the critical section. That has consequences. And what is done if the CPU finds that the execution was a bad idea depends on whether you use HLE or RTM. Under HLE, it just returns to the beginning of the critical section, which hopefully then contains your code for taking a log, and the execution is entered non-speculatively, which means that your log will be taken, and that's it. Okay, and the abort, if it should happen, happens fully under CPU control. Software learns nothing about the reason or whatever. Let me introduce you to the memory model here used. As I told you, this is not executed as far as other cores are concerned, but in the CPU, a cache line is, cached. There is no separate word for this. The cache lines have a status. It's either not used in the critical section, then it does not concern us, or it might be read, or it might be written. So, the CPU stores this state for everything it touches in the course of execution in the critical section, and at the end, it uses presumably the cache coherency protocol, but Intel hasn't told us that for sure, and compares its status of other CPUs. And now then looks, has anything I have read in the course of execution been written, then I cannot trust the consistency of my operations and must abort. The same is correct for having written stuff. And so we see that the locking is by hardware broken down into the most fine-grained form possible. Well, not possible, the most fine-grained form determinable in hardware. I'll come to that a bit later. There are obviously operations which you cannot do speculatively. If you're done on I.O., it's done. It can't be undone. So, there are operations which cannot be speculatively done. In, out, system calls, clearing the interrupt state, all of that isn't speculatively. Is specularizable a verb? Well, probably not. Would be made speculatively. Interrupts and page faults and task switches have the same effect. Also, the CPU store its writes. The CPU cache is limited, and if you run out of space, the CPU will also abort. There are three operations in RTM. In HLE, there is start this critical section and end it. It's a prefix. We have three operations in RTM. It's xBegin, which begins the critical section. Then it switches the CPU to speculative mode. And in addition to just beginning it, you specify if the speculation failed. Then the CPU will branch to speculative. That branching may happen at any time, whenever the CPU is in conflict, or at xend, which will trigger the full comparison and then either commit or roll back. Under RTM, in the market difference to HLE, you can do the abort in software. If in software you've detected that there is a condition which will not allow you to successfully finish the operation, you better fail soon. You only burn resources. And to make this nicer for the pro, you learn about the reason for the failure in the alternative. It's stored in the processor register, and if you use exabort, you can even send a short message to your So, now let's look at the algorithm which you perform to use RTM to remove locking. You could use it for other purposes. Right now, we will look only at locking. The operations I'm using here are those defined for libc to use for the pthreads library, but the algorithm itself is generic. You begin with starting with a critical section. This may fail if you try this on a CPU that doesn't do speculative execution. Then you check the log. This is necessary for two purposes. One, you may race with another CPU which has already and is now in its alternative code path, and then presumably it has taken the log. This cannot be done by comparing nodes, because the write to take the node has already happened, and in your perspective it would be too late. So the log to be taken, which can be seen by you've lost, you run incotention, you have to do the task switch and sleep. But even if you find the log to be free, this has a good purpose now. The log, or specifically its address, technically speaking, is in your set of cache lines you have read. If somebody else takes it, there will and a clean abort will happen. Now, after that, you do what you wanted to do, and after it, you check the log again. For two purposes. Once, in that case, you have written to the log, you need to free it, or you will deadlock, or somebody else has taken it while you were doing your critical stuff. So it's sad, you lose again, you have to give up and abort. In the alternative, that should be the more common case, hopefully. The log is free and you use xend. You can't do that unconditional xend. Node will cause a protection fault. Okay. This algorithm can be used in user space and in kernel space, and let us look how it is used in user space, which is done by the P library. Provides us with a large variety, and we would try to use most of them by execution. Pthreads itself is these days a part of glibc and provides this to the user space. So the aim here is to modify only glibc and to speed up by reducing contention everything that uses the pthread standard. The use of speculative execution in glibc as far as the current patch set is concerned can be controlled by environmental variables. If it uses speculative execution, it uses the xbegin and xend within glibc in the algorithm I had just demonstrated, And the alternative itself is also in glibc and consists at the beginning of the simple measure of actually taking the log. The xend, that is the release of the log, is a bit more complicated. There are reasons for this. First of all, speculative execution only makes sense if contention can be avoided. If all your users use by writing and reading, it makes no sense. You do have contention. It's unavoidable. Secondly, your critical section is limited in size by the CPU, and it is limited in the kind of operation. You cannot speculatively do I/O, which is covered by aborting the procedure on SUSE calls. In the RTM code, you learn the reason of the failure, and you can do statistics. So, the glibc evaluates the statistics, and if there are too much execution, it doesn't try. You can also force that by annotating your log. You can do it in two ways. That is, you can force the attempt actually, for what it's worth. What are the effects of speculative execution? An abort of a speculative section actually causes a performance event on the Haswell CPU, which in principle can be read by the Perl subsystem if you use kernel patches not currently upstream. Yeah. Speculative execution is every log in an RW log, whether you like it or not, because concurrent reads will succeed, while a write with the read will not. It furthermore gets you locking granularity at the cache line level. That is, on the level of every cache line you have used. This is not necessarily the fine grade level you have, because it may be possible that you have touched a cache line which is not critical, but or turns out to become not critical in the critical section, but the CPU cannot possibly tell. It would need artificial intelligence to do that. For the programmer, this means that alignment has now become even more of an important thing. If you put two things in the same cache line, you will get false negatives. So, how can we do this in kernel space? It turns out we can use automate emails. Some has all those are the bread and butter of kernel locking stuff. You just use them. There are a few old primitives like semaphores and for our purposes, we like to take as many logs as possible, but of course, a semaphore, it just doesn't fit any model. How would you do it? You have a defined number of entrants, and that can't be done speculatively. It just makes no sense. The exotics would in principle be possible, but they're too exotic. So algorithms are obviously displayed will be used, so the alternative is simply taking the log, and at the end there is some additional work. Again, in the kernel you have the same trade-off as in user space. It makes no sense to try something speculatively which you know to be out of seat, but you use that or something else. There is in the kernel the possibility that the CPU cannot do speculative execution, and we certainly don't want to publish a kernel flavor for speculative CPUs, which is at the CPUs. So we use for the UP when we use a spin lock, we modify the kernel code at boot time. Then the dynamic tuning, yes, this is done. Yes, it mustn't be done. We knock them out.
So, how can you dynamically alter this code?
You can't do it dynamically, but you can do it at boot time.
During the time, if you will decide that there are some good suppose this,
And if it does, all is well. If it does not, you walk your list of recorded spin logs, replace the xbegin and xends and xabports by NOP. Let's discuss this later. There is, as in user space, the dynamic tuning, which is a bit problematic because it requires you to add counters to spin logs. You have to record the effect of failure or success somewhere. Then the patches which Intel has posted are very, very specific to their instruction set, so they will reject it in favor of a common model with Perl. We do have some problems. The feature is not fully understood. For example, how about memory ordering? Then the active is competition is that speculative execution cannot be nested, and spin locks are nested quite often in the kernel. You can do an interrupt in a speculative action over cause and abort, which is something we do in the kernel as well. And of course, we are with our debugging equipment. It is built on the old-fashioned but sensible assumption that a lock is actually taken. And the point of speculative execution is not doing that. So debugging is short. There is a few more specialized uses of this. The KLM guys tell me that they would like to handle a pitching list in isotopics. Don't ask any questions to specifics here. And then we will have few further extensions planned to be provided by other members. I told you that the CPU cannot compute an optimal set of granularity because it does not know the semantics of memory accesses. There is, for example, the case you walk a list. You will have to touch a lot of next pointers and do something to the chart. Before that of the build method can't be avoided. But one line is producing instruction following CPUs that changes to such numbers and disregard. That will work efficiently. Now to status. The stuff is
what you see, and they look quite useful. There are patches for the kernel, but they need a major review. Okay? We are SUSE, we are great. You can't sue us for that. And please work for us. Questions, and please keep in mind that I'm not strictly speaking a glibc developer, I'm a kernel developer and usually do device drivers, not such stuff. But any questions, I'll try my best. It is not, depending on what you do. You can realize algorithms and execution without the possible to do it in another manner. Then you need to touch the individual software. If you want to remove locks only, that is locks in the pthread code, then you have double check with touching GC. So GC is 42K. For that purpose, you are indeed happy with only touching GC to check the kernel. I used 2 minutes too much. Shit. Come on.
That is a speculation. It is just
I mean, the chemist here is more corporation because the answering memory is stated. I mean, that's in a case for she weiter, and one is the same algorithm has been patched in the patches kernel. No. I mean, there's academic research on transaction memory, as they call it. But it's can't block elimination. You shouldn't need to think about how to use it. Just your skills are wonderful.
So we don't need to.
if you use a yes, you want to say muscle memory type. No.
There's no added modification on the application.
You could do more to modify the application. That doesn't mean it's necessary.
I guess from the slide, I guess at least I should write some code to register aborted.
Sure. If you in your library at the same time try to open something up.
I guess at least someone should register the report.
It's not necessary. It's the whole line. If you see, you see, then you can't say that.
Tell us there must be something. So register the report. If kernel also has to register the report.
There will be a generic award code for the type from. It just takes the log.
Awesome.
So language is can get away from the keyboard.
Only we don't need to modify those applications. And if we modify the case, we don't need to
Oh,
Very small supermarket. Just a moment ago, upstairs, I also want to order a map. We want not to see so maybe